Novel phages are candidates for phage therapy against pathogenic Escherichia coli. Phage therapy is a hot area of research that may provide a way to combat the looming terror of antibiotic-resistant superbugs in our future. This project has a focus on the bacteria enterotoxigenic E. coli or ETEC, which is the main pathogen responsible for childhood diarrhea in the developing world and traveler's diarrhea. Despite ETEC being susceptible to some antibiotics, the CDC does not recommend taking antimicrobials to treat infection due to increases in antibiotic resistance over time. Phages, which are viruses that attack bacteria, attack at the site of infection and are host-specific and appear to have relatively few side effects. The Sullivan lab had isolated 7 novel phages which we characterized against 11 ETEC strains. First, we used plaque assays to establish their host range, then we used adsorption kinetics, which measures the rate at which these phages attach to their host cells to assess the infection efficiency, and finally, we performed clearing assays to assess the infectivity of these phages. Only 3 phages infected an alternative host, with BDR being their original host. The adsorption kinetics of the 3 phages 8-1, 9-3, and 9-4 on the original host BDR proved to be underwhelming and confusing. We should see a dip in the beginning of the number of free phages as phages adsorb or attach themselves to their host. However, we do see very efficient adsorption and very large burst sizes in which the newly formed phages release themselves from the host cells on BDY. These 3 phages are more viable options for a phage therapy cocktail. To try and figure out why we were not seeing efficient adsorption on BDR, which was the original host, with our phages, we performed clearing assays at different multiplicities of infection, or MOI, concluding that our adsorption kinetic experiments may not have been done at a high enough MOI to see the progression of infection. Here you see a pink line, which is phage 8-1 on BDR, and this is red line is phage 8-1 on BDR as well, and this is at an MOI of 5. So at an MOI of 5, it is obvious that this phage is more able to clear our wells of bacteria. The ultimate goal of these projects is to develop a phage cocktail that will have a broad enough host range and high enough infection efficiency to be useful in the clinic, perhaps providing an innovative solution to the threat of antibiotic resistance.